For a square pyramid, that is a pyramid with a square base, essentially what we're looking at here is 1/3 of a rectangular prism, that is a rectangular prism that has been cut into 3 parts, and we're going to focus on the one by itself. So, in the same way that getting the area of a triangle is half of the area of the quadrilateral that it is part of, that it can be seen as part of, if we want to get the volume of a square-based pyramid, it's 1/3 of the volume of the rectangular prism it can be seen as part of. That is 1/3 LWH, or 1/3 B times H, where B is the area of the base, and we are assuming a bit of squareness here, so let's get another applied example to see how this works. We have that the Transamerica Tower in San Francisco is a pyramid with a square base. It is 256 meters tall, and each side of the square base is 52 meters long. Find its volume. So, here it's just a basic formula acquisition and application. You have to know that part there. We get that V is going to be equal to 1/3 of the base area, which is going to be 52 times 52, because it is a square base, multiplied by the height of 256, which unfortunately does not divide perfectly evenly, so we're just going to have to get an approximation here that this ends up having a volume of approximately 230,741 cubic meters. It's quite big, although normally we don't talk about buildings in terms of their volume, because you're not going to like fill a building with water or something, I guess. This isn't a disaster movie, but I guess it's good to know that that's what could happen. It sounds worrying. But that's the idea here with the volume of a pyramid. So let's keep building our shapes here by seeing what happens if you sort of sand off those edges as we get towards some of these more circular constructions, starting with the right cylinder.